All right, hello, my wonderful students. I'm turning the light back on. There we go. All right, so we have part 4 of foldable number 2. And for this one, once again, our parent function is already graphed. And this is a reflection over the y-axis. So just like we did on the top one, or part 3, we reflect over the x-axis here. Now we're actually going to reflect over the y-axis here. All right, so we're going to go ahead and get to it. So if you notice here, the absolute value is the negative is inside the absolute value. So we're not going to do it like we did before if we multiplied after by a -1. We're actually going to do it inside our graph. So it looks like this here. So we're going to go ahead and get started with it. So if we have a -3 here, we're actually going to put the -3 in here and multiply it by a negative. And negative times the negative is a positive, but it would actually really matter, because even if we end up getting a negative here, like we do here, the absolute value of it is just going to take it to the positive anyways. So if you notice, these are all positive here. And then we can see that these actual values are the same as these actual values. So it's actually going to be in the same point. So at -3, 3, at -2, 2, at -1, 1, 0, 0, 1, 1, 2, 2, and 3, 3. And that is because if we look at this here, and we can draw a line. I'm actually going to do it a little with a highlighter instead, because I want to kind of show you guys what it does. So reflecting, and then that's our reflective line. Sorry, it's not as straight. You guys should use a ruler. All right, so it's like this because if we were to fold this paper over, the graph would actually fall on top of itself. So it actually is reflecting over the y-axis like we were supposed to be doing. It's just doing it in a manner that it falls on top of itself anyways. So it's hard. It ends up being the same function because of the absolute value here. Because if you just take this here, the absolute value of -x is going to be x, which is our parent function. So that's why it does that. But it's it's a reflection. So any value that's on this side is going to go. So if you want to count, the easiest way to do it is to count here 1. And it's also 1 this way. So this point is going to reflect over there, as well as this point will reflect there. So just kind of, just like you said, it folds over.